Okay, good morning. Welcome to
FamilyMath number 536.
FamilyMath 536. So today we're going to revisit the Stephen Wolfram project that we did. I'm kind of zoomed in on it. So we're going to be using Mathematica today, and we're going to be using the code he wrote. And you remember what it does? What are we? Do you know what we're doing here, or do I need to remind you?
We're starting with a number.
Yep, we start with the number 1.
And we multiply by some number, which
Yep.
that's the numbers down here.
Right, we multiply by some number. In the code, it's called A, and A goes from 1 to
I
400.
don't know, I think we cycle the digits first, actually.
Right, and then we rotate. You're right. We rotate the digits left. So that means if we had it, and we're doing this first, we're starting in binary, but we're going to go into different bases. So we're starting with binary, base 2. And so if we have the number 1, 0, 1, when you cycle that, the digits left, the leading one goes to the beginning, and all the other digits move left. So 1, 0, 1 becomes what?
0, 1, 1.
0, 1, 1. That's right. And this is what we saw in base 2. And now I'm just going to zoom out a little bit, and I've expanded.
You just keep repeating that pattern.
Yeah, I've expanded it so that we can go up to the first 400 numbers, and I can just scroll through.
Well,
And you see we have all these different graphs of the numbers. Now, and what I want to do today is look and see if we can see any other interesting patterns besides what we saw previously. So one thing Stephen Wolfram noticed was that 13, how's that showing up on the screen, on the computer screen?
Pretty well.
13 had this very strange pattern of sort of chaos and niceness.
Yeah.
Okay, but tell me any interesting patterns you see looking at this. On the screen, we have up to 65 down at the bottom there. So anything you see that catches your eye here?
Well, I'm seeing that the squares seem to have sort of the same stuff, except for 25.
Oh, the squares except for 25.
Well, actually the even squares it looks like right now.
Okay, so let's see the even squares. 4.
4, and then 4.
16.
They have that same like line pattern.
Okay, what's the next square?
36.
36.
No, sort of. And then 64 has the same.
64 has the same line pattern.
Maybe
okay.
it's just the powers of 2 powers.
Yeah, actually powers of 2 it's 32.
Okay,
8.
so powers of 2, we have 1, 2, 4, 8, 16,
32.
32, 64. Okay, so powers of 2 seem to have line
They're
pattern.
not random.
All right.
I noticed that if you look at 65 here,
Uh-huh.
the random pattern is a lot bigger than the line nice pattern that we would like.
Oh, so unlike 13, let me see if I can make 65 bigger. Whoa, I scrolled down too far. Unlike 13,
But I wonder if the random pattern completely.
65 has lots of random and a little bit. Okay, is 65 related to 13?
Yes.
65 is 13 times 5.
Okay, so that's interesting.
But I mean a lot of them from there looks a lot like 65 like.
It looks like just some random and then lines.
I mean like even in the same ratio like 55 and 65 look almost identical.
Huh, okay.
Well, 96 is different.
Ooh, 96 is different.
It's got this repeating pattern here.
And oddly enough 48 you can actually see 48 in 96 I think.
Oh, okay. Are
So-
48 and 96 related to each other?
Because you have this
96.
You have this little bit here and that shows up right about there.
Okay, it looks very similar, 48 and 96.
I wonder if the random pattern will completely swallow up the nice pattern.
Huh, I don't know. But if we have that 48 and 96 pattern, what do you think maybe would be the next one in that pattern?
Maybe So it'll be 192.
192. Okay.
Or we could do 48 times 3. I just did 96 times 2.
All right. So, well, 192 is 96 times 3, and you
Or
think
96 times 2.
192.
Oh, 192.
Yeah.
Okay, so something's going on there. And what was 48 times 3?
That's 144.
144 does not. It has like
Does not look like.
It has a little bit of random on the edges.
Oh, yeah. So this is kind of the opposite.
It's mostly nice.
It's mostly nice with a little bit of randomness.
Yeah.
Huh.
But on 213, it's almost completely swallowed up. The thing
Hold on.
213 right there.
Sorry. Wow. Okay.
It's a
But we did find 192 was nice.
And going back to our powers of 2 pattern,
Uh-huh.
we can look at 128.
Yeah.
See, it's nice. And this is 256 here.
Huh.
That's nice.
It seems like those are like the only ones that are refined and nice and refined.
Well, look at this one right here.
191. Wonder how that relates to anything.
191.
Wait, go back in again. It's looking different. Like, if you zoom it back in, make it smaller, the lines start to look different. They're different thickness.
It's probably it's probably just a display problem.
Yeah.
But let's make 191 big
It's
as we can. What do you think's going on with 191?
We have these L's.
it's like yeah. And then we have this dot on the end, and I guess it just starts over.
Huh. So 191 is a very strange pattern. Maybe we can investigate that a little bit more. Okay. Well, look. So we've looked at base 2 for a while. Let's go up to base 3. Okay.
Okay.